Dear members of the doctoral jury, dear colleagues of the faculties of Economics and Business Administration and of Sciences of Ghent University, dear friends and family of the promovendus, dear Kevin, it is with great pleasure that I welcome you at the public defense of the doctoral dissertation of Kevin Hoefman, dissertation entitled Live Agent-Based Models. A warm welcome to all of you online in these somewhat difficult times. I can tell you that we are more than 100, which is great. It is great because even if it is online and in difficult times, we will and we should never forget the importance of young people obtaining a PhD. The doctoral degree is the highest academic degree a university can grant in Belgium. So each time someone succeeds in obtaining this degree, it is a proof of successful education and training. Each time someone obtains this degree, it also proves that a young person has acquired the necessary skills to become an autonomous researcher, a scientific researcher. And often the acquired scientific expertise of a new doctor, well, it will not only benefit science, but it will also benefit society as a whole, when the expertise is used to tackle questions or problems of societal importance. Ladies and gentlemen, today the faculties of Economics and Business Administration and of Sciences of Ghent University, through this public defense, they will officially attest that Kevin Hoefman has successfully completed his doctoral process and that he will be entitled to call himself an independent researcher as Doctor of Economics and of Science, Physics. So this is a moment of great joy. Before starting the procedure, I want to present you shortly the doctoral candidate. Kevin Hoefman, he was born in 1975 in Brugge. He obtained his Master of Science in Electronics and ICT Engineering at Ghent University of Applied Sciences in 1999, and he obtained the master degree, Master of Science in Banking and Finance at Ghent University in 2011. He started working as a doctoral researcher at our Department of Economics in Ghent University in October 2014. He is a member also of the Interdisciplinary Research Lab M and the Interdisciplinary Complex Systems Institute at Ghent University. He took several PhD courses on agent-based modeling in economics. He followed courses in advanced microeconomics, advanced econometrics, as well as several courses on, I was surprised, but it is here, on old Babylonian economic and legal documents. So he's, and he did all these courses as part of the doctoral schools program at Ghent University. Now, Kevin, he presented his research papers at several international conferences. And let me mention the 2015 conference of the Network Science Society in Zaragoza, and the 2016 conference on complex systems in Amsterdam. He also participated, I heard, on the EVE FunFest for computer gamers in Reykjavik in 2016, and the EVE FunFest conference or community in Amsterdam later years. So he presented his work at conference. He also published his research. He published his work in temporal network epidemiology in 2017, in PLOS ONE in 2018, and he has forthcoming publications in political analysis. This about the candidate as an introduction. Now, throughout his doctoral process, Kevin was guided by committees, and there are two committees that play a crucial role in the doctoral dissertation process at Ghent University. First is a doctoral advisory committee. As soon as a student starts his doctoral research, the faculty appoints an advisory committee. And this committee accompanies the candidate throughout the process from the beginning until the end. This committee provides scientific support and scientific input and critically evaluates the student's progress. This is throughout the doctoral process. And then second, there is an examination board. And this board is appointed after the doctoral candidate has submitted his dissertation. Now, the examination board has interviewed and challenged Kevin during the pre-defense. It is also this examination board that has allowed Kevin to the public defense. And that's why we are here and meet today. So let me immediately present to you the members of this examination board. The jury, the examination board is complete. The members are here and I'll present them now very briefly. But when we move to question time, I'll say a little bit more about each of the members. So members of the jury are Professor Dr. Koen Schoors, who is from our Department of Economics, Ghent University, and supervisor of Kevin's dissertation, of Kevin's doctoral work. Second, we have Professor Dr. Jan Rijkebus, also supervisor and a member of the Faculty of Sciences of Ghent University in physics. We have Professor Dr. Luis Rocha, related also to the Department of Economics and to the Sciences Department in Physics from Ghent University. Fourth, we have Professor Dr. Bruno Merlevede from the Department of Economics of Ghent University. We have Professor Dr. Nele van der Sikkel from the Faculty of Sciences, Ghent University. And then I especially welcome two external members of this jury. That is Professor Dr. Jacques Temperet from the University of Antwerp and Professor Dr. Serge Galan from Sciences Po and CNRS in Paris. I'm Freddy Heilen. I'm here as chairman ad interim, replacing the dean, who could not make it as chair of this examination board and public defense. So as I said, I'll say more about each of the members of the jury when they ask questions later. Now you have to all please excuse me that for a while, a brief moment, I will now turn to Dutch. What I will do is officially open this special examination session, and this requires some formal expression in Dutch. But before I do that, let me first mention that unless someone in the audience were to object, this event will be and is being recorded. So if someone objects to the recording of this event, he or she should speak now. Since I hear no one, so we will record this event, this public defense. As I said, a few words in Dutch now to officially open. Geachte aanwezigen, dames en heren, hierbij verklaar ik de buitengewone examentijd ter beoordeling van het proefschrift ingediend door de heer Kevin Hoefman tot het behalen van de graad van dokter in de economische wetenschappen en in de wetenschappen fysica aan de Universiteit Gent voor geopend. Ik stel formeel vast dat Dr. Kevin Hoefman voldoet aan de voorwaarden gesteld in het decreet van 12 juni 1991 betreffende de universiteiten van de Vlaamse gemeenschap. Dat hij al de voorwaarden heeft vervuld, voorzien in het bijzonder examenreglement voor het behalen van de academische graad van dokter. Ik stel ook vast dat de procedure verliep overeenkomstig het facultair reglement. De examencommissie heeft daarover beraadslaagd en heeft kennis genomen van het verslag van de voorverdediging en van de individuele verslagen van de leden van de examencommissie. De examencommissie heeft beslist om Kevin Hoefman tot de openbare verdediging toe te laten. Het is nu aan de doctorandus, het is nu aan Kevin om een uiteenzetting te geven over de inhoud van zijn proefschrift en dat gedurende maximum 30 minuten. Ik geef als laatste mee dat de voorschriften in verband met de minimum- en maximumduur van dit openbaar examen. De minimumduur is 1 uur en de maximumduur is 2 uur. So let me turn back to English. Ladies and gentlemen, I will now invite Kevin to give an overview of his research and his main findings. Let me also tell you that he has a maximum of 30 minutes to do this. After these 30 minutes, I will turn to the members of the examination board who have a last chance to challenge Kevin and to ask their final questions. After question time by the jury, there is also the opportunity for people in the audience ask questions to Kevin if they would like to do that. Now, all this will last for a minimum of 1 hour and a maximum of 2 hours. So please, Kevin, you have the floor.
Thank you very much. Can everybody hear me? Am I hearable?
Very well,
And
yeah.
do you see the presentation?
Yeah.
So thank you. Welcome to my presentation. In 2009, at the height of the financial crisis, complexity scientists Doyne Farmer and Duncan Foley concluded that we needed agent-based modeling because there were problems with the current approach. And they wrote, in today's high-tech age, one assumes that the models are solid, sophisticated, quantitative, and they are not. Both models currently in use have fatal flaws. And as a result, the leaders of the world are flying the economy by the seat of their pants, which is a strong statement. And they suggested there's a better way, agent-based models. We need these things. If we fast forward to 2020, reliable macroeconomic agent-based models still don't exist. So we could conclude that the leaders of the world are still flying the economy by the seat of their pants, which is fine until it crashes, and then it's not so good. So we have to take a step back to put this into context. A long time ago, probably as long as we can tell, people have cared about the economy. And economic activity actually predates writing and led to writing. If we look at Babylon, for example, the 18th century BC had palace economics with the king actively involved in economic management. And if we go to the later Babylonian period, we find time series of monthly market values of 6 commodities spanning 7 centuries. When most economists think that at this point people were doing barter economy stuff. However, there was no modeling because, and it makes a perfect sense, if you believe that the gods decree the fate of man, then why would you model? The only thing you could model is the will of God, which the Babylonians actively tried. But we have to look forward to the 17th century to go into a more systematic approach, and this is what we consider the birth of modern science. And we get natural experiment to understand what's going on. Maybe God was the great clockwork maker, and we could, with research, with natural experiment, find out what he was planning for us. And it's until we have to wait until the 19th century before we get to mathematical economic models. Now, in my dissertation, I explain this stuff. I won't now because we know Mary Morgan in 1990 concluded that by the 1950s, this ideal of econometrics, which is still going very strong, but the ideal of it, the union of mathematical and statistical economics, had already collapsed. This didn't stop people from using it anyway. And by the 1970s, so in the 1970s, there was a big fight. Robert De Lucas critique Keynesian modeling and suggested, no, we need dynamic stochastic general equilibrium models. I could explain those. I won't either, because in 1986, Kenneth Arrow, who's like a god in the field, he provided the modern interpretation of general equilibrium. He said, this whole general equilibrium stuff has major problems. It has to do with rationality, etc. It's a brilliant paper. People listened. And, well, you had to look for alternative ways of doing this sort of science. So in the 1990s, we get econophysics, when physicists and people from all over the hard sciences, if I could say that, try to help out. Let's put it that way. And there's different strands. One is sociophysics, and I'm very fortunate to have Serge Galam in my jury. He's one of the founders of this approach of applying physical models to social and economic problems. And another interpretation was, okay, maybe we can use this rather new way of, maybe we can use computer simulations. And that brings us to complexity economics. Now, I have a riddle for you guys. How do you write a simulation for something you're still trying to understand, like the economy? It's hard, but there is a solution. We applied agent-based modeling. This already was around. You could do agent-based modeling before computers, or you can do it without computers. But the idea is to program the individual behavior of agents and then program their interaction and just let the simulation run, see what comes out. This is an agent-based model. However, there was another problem, and we're still struggling with it. This is where Farmer and Duncan Foley. The problem is microeconomic theory. Understand how individuals act economic decisions. The book I'm showing is, everybody should read it, at least the first couple of chapters, but this came out in 2011. This is after the call for macroeconomic agent-based models. So we're trying to model people without a proper understanding of this. And the last 10 years, our understanding of how people actually make decisions has made major progress. Sorry. So if we don't know how these agents work, then how do you program them? What do you write? And the solution that I'm proposing, or we're proposing, is we don't program these agents because we can. There's better now. Advances in computer technology during the 80s and early 90s enabled the development of agent-based modeling. We know that. But in the last 2 decades, further progress in computational power made possible the creation of virtual worlds populated by large communities of real people. And contrary to simulation, the phenomena observed in these virtual worlds are causally driven by actual human behavior. These environments lack scripted macro and micro behavior. The micro behavior comes from real people, and the macro behavior is emergent, which is a fancy word for let it run and see what happens. The software of these virtual worlds provides only the mechanics of the environment. These open-ended environments are actually rare. The idea of we take a game and use the game to do simulations. There's specific requirements, and a couple of examples where we find these are Second Life, which is considered a virtual world, not a game, although you can make little games inside the virtual world, and EVE Online, which is a massively multiplayer online computer game set up to be open-ended. These are discovered models. It's important to understand that they're identified ex post by the researcher as useful for understanding real-world dynamics, and that's what makes them models. Models are never real, but we use them to understand reality. To date, no purposefully built live age-based model exists. This could be an interesting collaboration between academic universities and University of Applied Sciences. Just an idea. To be a live agent-based model, a virtual world should be large enough to support complex interaction between participants, contain the dynamics that we actually want to study, for example, market behavior, and feature behavior that is not scripted. Participants should not be pushed into built-in incentives, and that's where most games defeat the bad guy. And then if people defeat the bad guy, that's not emergent behavior, that's scripted behavior, that's not useful. Such worlds, if we find them, offer unique properties attractive to research. A computer keeps track of the state of everything in the game. And so you get very detailed data sets. And in economics, this is difficult to find. Simulating a real economy it's actually impossible. So where do you get your data sets? Properties of everything existing in this world, they're precisely defined, which is really good for the researcher. The data is available about the entire population of participants, really good for the researcher. And all participants can be given access to, so also the participants can have access to these details, which means that they know the decisions they are making. You're under conditions of almost perfect information. Also, participants tend to have more homogeneous preferences than in the real world, because virtual worlds still are simpler than the real world, and this is exactly what you want in a model. Now let's have a look at EVE Online. EVE Online is an open-ended, massively multiplayer online game set in a science fiction universe created by an Icelandic company, CCP Games, and has been running since 2003. More than 500,000 players are competing in this virtual world. They get to engage in a variety of professions and activities, mining, manufacturing, trading, and a lot of fighting as well, but they're not pushed into any of these activities, and that's super important. And CCP Games is collecting detailed economic time series data since 2003, which in the scope of economic research is quite awesome. This is me in 2016 at the headquarters of CCP, collecting their data, of course, with permission. Cheers, Edwald, for that. So, empirical contributions from this data so far are 6 papers. One is forthcoming, and I will go over 3 of these papers, the papers that I've included in the dissertation. So first of all, the first paper dealt with price versus quality, and using EVE Online market data, can we answer the following questions? What is the relationship between price and quality of an economic good? And this is a question that has been going on in economics, in marketing, since at least the late 1900s. Late 1800s, sorry, late 19th century. A guy named Veblen did the first systematic investigation of this question. And if we can use this detailed data to look at what happens in our model, are there surprising contributions to the price? Yes. Data. EVE Online contains 12,709 distinct items, so this is important. There's lots of stuff to trade. Which is why you get market forces, why you can't corner the market. You get natural prices emerging. Our analysis focuses on ship modules such as weapons and defensive systems. They're popular, they're highly traded. And there are 296 different types of modules, module classes, and we select the 20 most traded just to have deep markets. Our data set is 2015. So, for example, this is one type of module. On the left, you can see what it looks like in the game. It's a ballistic control system. Ballistic control system. So all these items, I'm highlighting the names, all these items are sort of the same item, but with different flavors. One is better than the other, and I'll show you that immediately. You buy these items because they make your weapons in the game do more damage. For example, the most basic item plus 15% damage, and the most fancy, expensive, super rare item plus 27% damage. So this is interesting because the best item in the game is not even twice as good as the most basic item. Now let's take a look at the price, what people pay for this stuff. The most expensive item is enormously expensive compared to the more affordable items. And because of COVID nowadays, everybody has an idea of what this is. This is, of course, an exponential relationship, which we can already see by eyeballing the price. So that was already very interesting. If we then do this across 20 different types of items, we see the same thing. This is just one type of item. On top of that, if I highlight items 11, 12, and 13, and you take a quick look at that, you'll see that the quality of these items is identical. So players know, they go to the market, 2/3 of the items are traded in the same place. And you want one of these items. It's a good quality. It's not the basic. It's not the most fancy. And they have exactly the same stats. Now, surprisingly, some players are like, okay, let's pay 30% more than the alternatives, which is odd. It's almost irrational. You don't expect this as an economist. We thought actually that this was, our model was flawed, that this was strange. But then when we factored in a rarity of an item, and you see rarity 2, 3, 4, that is, each category is 10 times more rare than the previous. So 1 in 100 items, 1 in 1,000 items, 1 in 10,000 items. we saw that people actually paid for this, even though it should make no difference. You go to the market, why do you care if it's rare? So we found that people pay for the purely functional quality of items, but also for the social qualities. The only reason you would want a rare item is that you can show off with it. And there was a second meta group, a second social quality in this data as well. And if you see at the left and in this column, I'll show you the only difference it makes. A Tech2 item has a different icon. And then if you go to storyline, different icon as well. Faction, different icon. And then the most fancy icon in the game is purple. So you can pay a lot of money for the only benefit of having a purple item. The stats, everybody knows them. Everybody knows what the items do, but people often pay 10 times more for these luxury items in category 5 or 6. Same stats, 10 times more because I want to show off with it, which is pretty awesome. If we tally the results, we can show it in one figure. Note that this is the logarithm, the natural logarithm of the price. And if we then look at the items per minute, we see more advanced, more orange value pay for this. Go to the higher and higher category of items, the more and more social value plays a role. Interestingly, if we look at the model that we used, I'll show that in a second, but we compared different ways of looking at the data. Linear quality, log linear, so exponential, without social value, and then with social value. With social value, R square, the normal people word for that is goodness of fit. Our model fitted 95% of the price behavior over these items in this game. So you can explain 95% of what happens with prices, which is insane. We initially thought something had to be wrong. The model we use is the logarithm of the price is explained by a constant, then 2 to 5 functional quality characteristics, so the F is the functional, then a term for the rarity of the item, and then MG is metagroup. So this relatively small model of prices in the game, which is pretty awesome. The second publication we made dealt with diplomatic relations. Using even line alliance relationships data, can we answer the following questions? How well does a social theory that is used all over the place, structural balance theory, how well does it hold in a virtual world? And how do coalitions behave in this virtual world? So this theory has been applied to the First World War, the Second World War. How do countries relate to one another? How do coalitions shift? That sort of thing. Our data is Evoline players, they can unite in the game to form alliances, and the biggest alliance has 28,000 players. Alliances then also, but purely emergently, there's no support for this in the game, but players do it anyway. Alliances can coalesce into coalitions. Everybody in the game knows these things exist, but they emerged spontaneously. They weren't implemented in the game itself. And the data we use is we have 607 alliances over a period of 437 days, and we look at their relationships and then how things evolve. Structural balance theory looks at any three alliances or really any three anything. So we look at that very quickly. The model has been used for classrooms, for groups of people. You get clique formation in classes of students as well. And the image here shows 3 people in the background who get along and somebody who is being excluded. So you can analyze this with structural balance theory by looking at all triplets of participants in the group you want to study. First of all, students ABC in the background are friends with one another. Plus is friends, 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 and they form this clique. It's strongly balanced. There's no reason for this to fall apart. It can, but There's no reason for it. And this embodies the concept, the friend of my friend is my friend. The opposite of that is the situation where you have the three persons on the left if the guy tried to be friends with both girls. So the guy would be person C, and the girls, just imagine here, don't get along. A and B have a minus. This is doomed to failure because both girls would, of course, distrust the guy because he's friends with the other person. It doesn't work. We see this in the game as well. If you try this, it doesn't work. We call it frustrated because it doesn't last long. Then we have the weakly balanced situation. That is the situation where you have the three people on the left if you keep them as they are there. Persons B and C are friends, and they both exclude person A. There's no reason for that to be unstable. And this is the friend of my enemy is my enemy, that concept. And then we have weakly frustrated. It's just nobody gets along. And the reason why that is sort of unstable is that all persons in this relationship have an incentive to team up with the other person and therefore become the weakly balanced situation. So we want to observe how changes in underlying relationships affect the political situation over time. And we can do this with a temporal network technique. This looks scary, but first of all, we have in this case 7 participants. And just imagine that the red dot is a person and he's angry. In time step 2, we just look at the same people, but now you see that the angry person is still angry and he affected another person. And then you can build this model for time step 3, time step 4, and eventually you get a big model. It's a temporal network. To analyze our even line alliance data, we need to build this network of triads of alliances, because it's structural balance, connected with each other and through time. So just to show you, this is the alliance network now, a subset of it in even line. And we build triangles of it. How does it work? We group alliances 1, 2, 3, and you get triangle 1, 2, 3, 1, 3, 5. And the connections are the shared pairs of alliances. So if we quickly look at that again, 1, 2, 3, 1, 2, 3, 1, 3, 5, 1, 3, 5, and you do that for all the triangles you can find. Now, there was a catch, sorry. With 607 alliances, there is 607 times 606 times 605 divided by 6, or 37 million triads. It's a big network. And that's the small version of it, because you have to duplicate it over 437 days. So you get 16.2 billion triads. That's not even looking at the connections, because that gets exponentially worse, quadratically worse. 29.4 trillion connections in this network, and at 88 bytes per connection for the programmers, shout out pointer size in 64-bit. Constructing it would take 235 trillion bytes of RAM, terabytes of RAM. So while a typical computer has about 32 gigabytes of RAM, so this is completely impossible. We could solve this by, and if you would ever want to make a temporal network implementation, use a state machine and exploit the topography of the network if possible. In the dissertation, this is explained in detail. You can read it if you want. If you apply these optimizations, by applying them, we could reduce the network size to only 3.58 gigabytes. Standard network packages aren't able to do this because each network is unique. We use the unique topography of our network, so we couldn't use a standard approach. The results were mixed support for a structural balance theory, which you can find in the paper. And we found this was interesting, that a multipolar world is more stable than we expected. This looks scary, but if you just cluster the alliances that get along and you look at the enemy relationships that separate them, then you get a stable clustering which has more than 1 or 2 a classic powers that balance each other out. And this is on coalition level. Remember, at the weakly frustrated situation, where if you look at the coalitions in triplets, this is actually quite stable. Not as stable as pure friendships, but this didn't go away over time. For the programmers among us, class, this is what a triad class looks like, and this was the optimization. Instead of having millions of connections, we could reduce it to 3 per triad. Again, details in the dissertation. And then we had the measuring propagation paper, which was also cool. Using the temporal network analysis software from the previous chapter, can we look at common patterns in different network data, different time network data? The data we used was a data set on Russian interbank market. A Twitter data set where people were tweeting to each other about vaccination, and we could track the mood, and the Evenline alliance relationships data set that we just used. This is for the banking experts. This is fun. I just picked one of the 3 data sets, and we start from the start. We have 8 banks. One is a zombie bank at the start of this data. 2 healthy banks, a stressed bank, another zombie bank. So it should be dead, but it isn't. And 3 healthy banks. And then we look at every time step, how does this propagate through the network? So at time 2, we see that the first zombie bank is still a zombie bank, but the other zombie bank is affecting other banks. And then you can track it through time. And eventually here we get to a situation where the regulators are starting to clean stuff up because zombie banks are being closed down and the rest of the banking system returns to a more healthy state. Results we found, so for each data set we documented the specific results, see paper. We also found that for these 3 data sets, the cumulative cases were highly correlated with magnitude. Just I won't go into details, but the interesting thing is that this was true for these data sets, but we know from the literature that it's not necessarily true for example, disease simulation. So that's a cool thing to find. And then we also said, this is a cool paper because we're demonstrating the use of temporal networks, and we are hoping that this will gain a wider acceptance. To summarize, live image-based models are virtual worlds which channel emergent behavior causally driven by real people. The data collected from these virtual worlds allows us to shed new light on old and new. If you to read the full dissertation can be found in this link, I'll maybe show it later or drop it in the chat or something like that. So I can imagine that there could be questions about this. And I will stop sharing.
Okay. Kevin, thanks a lot for a very interesting, illuminating and multidisciplinary presentation. I think we all enjoyed your presentation, which also gives us time now for the members of the jury to ask questions. And what we usually do, we start with the member of the jury that is the longest distance away from us, and that is Professor Serge Galam. I think Serge is hearing me. So Serge Galam is full professor of social physics at CEVIPOF, and CEVIPOF, that is a center of recherche politique related to CNRS in France. His fields of interest are social physics, opinion dynamics, and disordered systems. He published in many journals, peer-reviewed journals, such as the European Physical Journal B, the Journal of Mathematical Sociology, the European Journal of Social Psychology, and Physica A. Professor Galam, you have the floor.
Can I interject for 1 second? Sorry. Paul and Tom, could you switch off your camera, please?
Tom is, yeah, okay.
Thank you.
Okay, so thank you very much for this short but really nice presentation. And I enjoy reading your thesis and really for many reasons, and not only interesting, but I learned a lot of things. And it's rather rare to have a review of economic pointing to all the weaknesses of the field and also giving the open path where really new contributions are needed. And you did some nice contribution in this direction, and really I wanted to congratulate you for this work.
Thank you very much.
So I will not ask about a specific question, because one can ask a lot, as you are touching to many different aspects around economy, where how to really overlap with other disciplines and create new challenging tools which we need, and you have few ones. My question is, people doing the kind of research as you just did now, and also you have the chance to have Kohn and Jan, which are really at the front of this interdisciplinary research and discovering, and there are not too many places. So I think Ghent University is one of the more innovative and the more advanced today. So from the beginning of the thesis and nowadays, that means in few words, how did you change? What did you learn, not on the detail, but about your future, for instance, about how you will deal with either research or working in the real world, or whatever. That means how your view of the world and the economic world in few sentences has changed, and how you see your near future.
Thank you very much for the question. Very good question. What does my future look like? Maybe so you're right in the sense that I try to sort of pinpoint or point at the issues that are ongoing in economic research. I definitely don't have the illusion that I will fix some of these anytime soon, because if we consider what we're trying to do, we're trying to predict the future. And the future has always, of course, interested people. People have tried for millennia to know what will happen, but it's just complex and in all meanings of the word. So what is the future of complexity research going to look like? No idea. Am I going to play a small part in that? Hopefully, because it's really interesting. Immediately, one of the papers we're working on, one of the ideas we have with Jan as well, is to look at an alternative explanation for the exponential pricing behavior that we found in the hedonic pricing paper, because the assumption of the theory is that people quantify precisely the quality characteristics of a given good and then assign a price to that. And that's, of course, in the real world, a stretch. If you look at a bottle of red wine, precisely where the price goes is almost impossible. Nobody does that. So we are looking at a heuristic explanation for that. So that's what I'm working on at the moment.
Thank you. And I would say that I am ready to bet on your future as a personal instead.
Thank you for your kind words. Freddy, you are muted.
Yeah.
And Rudy has his hand raised.
Not by accident. No, but we give the opportunity to people in the audience after the members of the jury. So
yes.
Second member is Professor Jacques Tempere. He is full of theoretical physics at the University of Antwerp. His fields of interest are condensed matter physics, quantum mechanics, and econophysics. He has published in peer-reviewed journals such as Physical Review A, Physical Review B, Physical Review Letters, and the Journal of Low Temperature Physics. Professor Tempere, you have the floor.
Thank you. And thank you, Kevin, for again a nice lecture. I very much enjoyed your thesis. Coming from physics and from condensed matter physics, we are used to putting very simple things on networks like little magnets and treating these little magnets like our agents. But it's a really nice idea that you can now use computer gamers as your lab rats and as your agents. Right? So the question I would like to ask you, we already discussed it a little bit, but maybe you can kind of summarize summarize for me is, well, now you have this nice environment to do this, to do this simulation in, and it's already much more complex than the simple agent-based things that we have. But still, it's different from the real economy. There's still some simplifications. So, what do you think are the most important differences? Even though it's a complex thing, what are the most important differences if you would compare it to the real economy? And in the sense, I'm looking for the shortcomings that would be coming from that. So the shortcomings due to the fact that it's still not the real economy. What do we have to be careful about when we try to test our models of the real economy on this simulated economy, this massive online game?
Yes. Thank you for your question. The shortcoming, the major shortcoming is that you have to find these models. You have to discover them, and if they're not there, you can't test whatever you want to test. The thing is, so clearly there are biases in the sense that the people who play the game are self-selected. That's always a danger, but the thing to keep in mind is that in economic, especially in economic research, you always have that as a problem. Many social economic studies are done on 18-year-old first-year participants who, and then we pretend that these people are representative for the population we want to research. The major problem in economic research is that you can't build an economics lab. As hard as it was to build CERN to do particle physics research, at least you can build CERN. Building a second economy to simulate or to compare to a first one is literally impossible. This was a major problem with the financial crisis of 2009. For example, Iceland, they didn't bail out the banking system, and other countries did. So then you can say it was a good decision or a bad decision, but you'll never know because you can't simulate a second Iceland. So compared to the problem that all economics research has, the limitations of self-selection, population biases in these virtual worlds is actually not that bad. The major problem, the major problem, well, twofold. If it doesn't exist in one of these games, you can't research it. And also there's a tricky qualitative element to it, because as a researcher, you have to understand that this data is yes or no representative for the real world, and you can't prove that. In EVE Online, markets were at a level of complexity where we could use them as a proxy for the real world. But in other games, there's also markets, and maybe they won't be useful. So you have to make a qualitative judgment as a researcher whether this data means something or is completely spurious, and that's tricky to do. So that would be a major disadvantage. Yeah.
So yes, there's the aspect, of course, of the self-selection of the people who participate in this study without knowing it, but also about the mechanics, right? That should be something. So, for example, is it a free market, or are there limitations? Is there state intervention? How does that compare to the real thing?
It's super interesting because EVE Online was deliberately set up with a libertarian perspective. So the makers of the game deliberately did not want to intervene in the market. And they did anyway, sometimes. The Plex prices have been manipulated without players knowing it. And the funny thing about that is it's exactly like in the real world. But collecting reliable data on that is, of course, a completely different story. But basically, when the game is set up to be a free market, then it can be a good proxy for a free market. Most computer games don't do that because it's a risk. If a free market can get destabilized, there's examples of other computer games where this experiment went very wrong. And you got hyperinflation in other games. So it's a risk, and the makers of EVE Online were almost unique in being willing to take that risk. But then you have a very nice natural experiment almost, because it wasn't set up as a research experiment. Yeah.
Okay, thanks for your answers.
Thank you.
Thank you. Next question will be asked by Professor Nele van der Sikkel. She is Associate Professor of Biological and Medical Physics at Ghent University. Her fields of interest are computational biology, cardiac arrhythmias, theoretical physics, network science, and physiology. She published in peer-reviewed journals such as the Physical Review D, Physical Reports, PLOS ONE, and Frontiers in Physiology. Professor van der Sikkel, you have the floor.
Yes, first of all, Kevin, congratulations with your nice dissertation. For me, it was also very new to read about an application of network theory on economics. So I read with pleasure your introduction, and you spoke about that economic models are unable to predict crises, and that they always fail in predicting that. So my obvious question and general question that I have for you is, can your live agent-based models predict a crisis in the economy, or what do you think about that?
Very nice question. We've actually looked at that with Koen. So I wouldn't say that no model is capable of predicting a crisis, although predicting crises is legendarily difficult because crises tend to be nonlinear, and general equilibrium models, econometric and the SGE models, assume linear relationships. There's some variants that are being experimented with, but in general, they assume linear relationships. So we know they tend to miss overshooting and undershooting, which is typical for crises. Of course, it's for a collapse. Interestingly, Second Life has been used to study real-world collapses. There is a case where the banking system inside Second Life collapsed in 2008 with the financial crisis. And there's papers on that. What we think happened is that because of the crisis, or even leading up to the crisis, regulators became more strict, among other things, against gambling. And there was virtual gambling for real money, because Second Life uses, via conversion, real dollars. There was a lot of gambling going on, and money had been borrowed to fund this gambling. So when the regulators cracked down in the real world, the game cracked down on this gambling, because of course the game is anchored, like the company has to answer to real world regulators. And the crackdown caused a lending crash in the game as well. Now, the holy grail would of course be that the crash in the game would happen before it happens in the real world, because then we can predict stuff. And we're currently looking at that. The preliminary results are inconclusive.
Okay, thank you very much.
Thank you.
Okay, thank you. Fourth member of the jury to ask his question. First question is Professor Luis Rocha. Luis Rocha is Associate Professor of Social Physics and Econophysics at our department at Ghent University. His fields of interest are complexity, networks, and epidemiology. He has published in peer-reviewed journals such as the Proceedings of the National Academy of Sciences, Nature Communications, PLOS ONE, and Scientific Reports. Luis, you have the floor.
Hello, thank you, Freddie. Thank you, Kevin. I think it was very enjoyable to watch your presentation, to read your thesis. I also learned different things, new things. It's always interesting exercise. I have a question. It kind of follows up a little bit what Jacques and Nelly asked. My question is about the validity of your model. I guess you are aware, a few weeks ago, your colleague, Dr. Andrés Belaza, he published a paper also using this EVE online game. So one of the conclusions was that people don't behave the same in online games as they behave in real life. So basically, people that live in aggressive countries or in countries with more aggressivity levels or aggression levels, they are less aggressive online. So there is basically a negative correlation in this aspect. He also found there are some different correlations with other quantities or other variables. So given that there are these differences between the real world and the online world or virtual world, how can you use an online game to as a model to real life phenomena? Like, what do you think about these in general?
Yes, thank you for your question. I think it works in both ways, and it will really depend on the situation. For example, CCP, I think it was in 2015 or 16, on their keynote presentation in the EVE FanFest in Iceland, they presented similarities between real populations of players and in-game behavior. For example, they looked at, because of course CCP knows knows a lot about their players, so they can look at the link between where people live, for example, and what they do in the game. And they found that if you look at the economic activity or in the industrial activity in the game per real world country, the two countries that were the most likely to be industrialist in game were Japan and Germany, which is of course very much correlated with real world behavior. There's also, I know, anecdotally, people who have a cultural identity will carry it into the game. But you can also have the phenomenon where people who play the game actually do the opposite. For example, if if where you live is violent, then maybe you want to play the game to be peaceful. So it's really tricky to look at the reasons why people do what they do. I would be careful with that, but it can at the same time be very interesting to look at these correlations. Yeah.
But then, do you think it's reliable? I mean, could you validate your findings, your online findings, and make this parallel to real life? Or the game could be more interesting, for example, for experiments to test theories actively, not just passively look into their behavior.
It's maybe too early to tell. My intuition tells me that it comes down to the qualitative element of, as a researcher, being careful with your interpretation of what is spurious, just a correlation without any meaning, and what is meaningful. It's very difficult, I think, to validate some of these essentially correlations that we find. Some of them may be spurious and others may mean something. Yeah, I can't give a better explanation than a better answer than that.
Okay, that's great. Thank you very much.
Thank you.
Okay, fifth question will be asked by Professor Bruno Merlevede. He is Associate Professor of Economics at the Department of Economics of Ghent University. His fields of research are international investment and trade, firm performance and productivity, foreign direct investment, and regional economics. He published in peer-reviewed journals such as the Journal of Banking and Finance, World Development, and Post-Communist Economies. Bruno, you have the floor.
Okay. Thank you, Mr. Chairman. So Kevin, let me first of all congratulate you on the nice, well, virtual work I received. I didn't receive a hard copy, so but it's all within the team, I would say. But I gladly join the previous members of the jury in expressing my admiration for your work. So nevertheless, there has to be a question, of course, today. So I want to ask something about the hedonic pricing chapter, in the sense that if I look at the thesis overall that you present, you have this very nice discussion about rational behavior versus heuristics, etc. And then you say we need this agent-based models to try to say in something more, because that offers a very nice setting. But then if I look at the hedonic pricing chapter, to some extent, it seems pretty rational what you get out, right? Because if you have, you put in a number of observable characteristics, and then you're actually able to explain 95% of the variation in prices. So I would maybe like you to comment first on that, and then maybe go to, because we are in a game, so rarity is typically something that is, I would say somehow specific in a game as well, because players in a game typically would care a little bit more maybe about rarity and being special than in real life. So maybe you can comment a little bit on that. But then specifically in what I had maybe in mind over here is, which I didn't see from the thesis, but if I look at these different armor systems and defensive systems, etc., are those attributes that you kind of need to, to get up in rank in these alliances in the game? So because in the end, there's only going to be one commander-in-chief of an alliance, and who is going to be that one? Maybe the one who has the biggest pockets and who is able to buy the nice fancy missile system, right? So I was thinking whether this type of mechanism could be at play as well in your findings, because you have this very steep price scheme, right? So would that be a potential explanation? Because people gather in these alliances, and if I want to get higher up in the ranks of the alliances, I simply need this. I need to buy this.
Thank you for your question. Interestingly, in a way, you would expect that you only have these variables, and therefore they will explain behavior. But initially, to us, that wasn't clear at all whether this model would actually work. And also, if you look at the literature, it's very, very mixed. People have been trying to understand this stuff for 125 years since Veblen, and there's still no consensus even on the functional form of this relationship. Many papers have looked at this. There's wine papers, there's car papers, there's a whole bunch of papers, and none come to a conclusion that say, okay, this model is clearly superior, which is in the real world natural, because there's so many variables that you can't, there's millions of possible models. And if you have a million possible models with a million possible relevant variables, the combinations you can never say something conclusively. But in the game, we knew, because of the simplicity of the game, we knew that the number of variables was fixed. There's only these variables that can explain the situation. And then it was interesting to see that under these conditions, you can look at different functional forms and really compare them. There's only one way that the linear form can look like. You put in the variables in a linear way and see if it fits. So here we could really distinguish between an exponential price relationship and a linear price relationship. Is it expected that it would fit so well? I would say in most economic relationships, if you get an R-square, a goodness of fit of 30%, you can be happy. Explaining 30% of the behavior with all these other stuff that is happening is in the real world normal. The fact that it fit so well, 95% is maybe afterwards intuitively obvious, but to us, it definitely was not ex ante. Your second question is also very, very interesting, because it seems intuitively reasonable that the person with the best gear, the best, most expensive stuff gets to be the leader. In reality, you're dealing with people, like tens of thousands of people, fighting huge wars over territory, and it's all virtual. But if you have territory in a virtual world, to your brain that seems very real and you will defend it. The people leading your alliance are the people who do the best job at helping you achieve that goal, and it's a collective goal, protecting your turf, taking the turf of other people. And it's certainly not the people who fly with the most expensive stuff, because in a protracted war that will work against you. You have to find a cost-effective way of waging war. So again, anecdotally, as a researcher, you can't prove this, but I know that the most expensive stuff is used only for the most expensive ships that will be fielded once every 2 or 3 years. We're talking Titan battles. But these ships are at the same time also prestige ships. And the way that these purple items are mostly used, in a war you want to be cost effective, but in alliances you can show off, and showing off doesn't make you the leader, but it makes you maybe a little bit more respected than the average field soldier in the alliance. So it does buy you social value, but it doesn't buy you leadership. Leadership in this game, it's you would say it's a game, but these people have been playing this game for years and years and years, and they take it very, very, very seriously. So these wars, you get the Red Queen effect. These wars are highly competitive. Any benefit that one alliance makes is almost immediately going to be copied by the other alliance, and you get almost an equilibrium situation where you have to be cost effective, where you have to be clever, you have to be a social leader, because you have to keep people around. If you're an asshole, you won't win, because people will leave and go to the other side. So it's very interesting to watch this stuff going on, and it's definitely not a buyer's game. Leadership takes a lot more than in this game, and in the real world, of course, than showing off, which doesn't mean that showing off doesn't happen. It happens all the time.
Okay, thank you.
Thank you. Kevin was lucky to have 2 supervisors. And one of the supervisors is Professor Jan Rijkenbus. He is full professor of theoretical physics at Ghent University. His fields of interest are computational physics, statistical physics, theoretical nuclear physics, and interdisciplinary sciences. He published in peer-reviewed journals such as the Physical Review Letters, Physical Review C, Scientific Reports, PLOS ONE, and Physics Letters B. Jan, you have the floor.
Thank you very much, Mr. Chairman. I hope my mic comes through.
Yes.
Good.
You're frozen at the moment.
Jan, we lost you.
And you're back.
I'm back in town. Yeah, okay. I think you touched on a wide variety of topics and succeeded in bringing those together in a really coherent way in your thesis. I also would like to stress that you made pivotal contributions to the data cleaning process and the development of software. I mean, things that are usually not well highlighted during presentations like this, but I really would like to mention that. Okay. My question concerns the importance of demand dynamics that you already stressed during your presentation. And to cover the dynamics in networks, you developed this wonderful and very efficient piece of software to study temporal webs. And my question actually concerns the flexibility of the software that you developed to be applied to new quote-unquote situations. First of all, I think it would be great for the audience that you could just summarize like the basic ingredients of your software development and what the new ideas were like. And second, for example, would it be applicable to the contact tracing issue, which is kind of a nice issue given the current situation? And I mean, one of the virtues that you mentioned in your thesis that your new methodology is very powerful in covering the transmission activity through time. Okay.
Yeah. Thank you very much. Yes, the tricky thing about the software, so theoretically, a temporal network is like non-temporal network without the time component multiplied into time. And that's a nice concept. And in theory, for any analysis, you would have to build it like this. But then with large networks, you get into memory constraints, all sorts of constraints. I mean, the theoretical size of a network is infinite, so you can't model that on a computer. The optimizations we did, one was because we knew that we had to go through time sequentially. We could look at 2 data slices at a time and not more than that. So we had to have the data for time t and time t plus 1 in memory, but the other data at that point wasn't really relevant, which is why or how you could use a state machine implementation. So instead of looking at 437 time slices at the same time, we look at 2 at the same time, and then we iterate through the network. If you want to track things through time, that is mostly how you would want to do it. When it wouldn't work, for example, if at a certain point you want to look back 10 steps or 5 steps or like more than one step, then you would have to put more data into the network, and then you'd hit the same limitations again. The software I have at the moment could be generalized to any temporal network or time set of data that involves network dynamics. If you only need to track 2 steps at a time going forward. Going back, you could do it as well. So for COVID situation, for tracking what happens in the network of people, because I know that's very hot at the moment, the tracking data, it would definitely work, and it's something we could actually generalize. At the moment, software is entirely in C++. The big dogs in complexity science who have been doing this longer than I have, they write C++ libraries for Python, and then you can script the library, which gives you very rapid results with the speed of C++ still behind the scenes. So that's something we could do. The limitation would be that backtracking and forward-looking wouldn't be possible, which is why it wouldn't be a general temporal network solution, but it would be a 2 steps at a time going forward temporal solution for any kind of data, because a network is, of course, just a network.
Okay, thank you very much.
Thank you.
Thank you. And last but not least, Kevin's second supervisor is Professor Koen Schoors. He is full professor of economics at Ghent University. Among his many research interests, we have institutional economics over financial markets and international banking, to economic history, Russia, and econophysics. He wrote several papers in journals as the Journal of Banking and Finance, the Journal of Development Economics, and the Journal of Money, Credit and Banking. Moreover, we know him as an often heard voice in Belgian media on economic policy issues. You have the floor.
Thank you, Mr. Chairman. Kevin, first of all, thanks for your great presentation and congratulations. But I will have more time later to embark on my congratulations and be more clear about it. So I will, for this moment, stick to my question. And my question is going to be a bit in line with the question of Bruno. As an economist, I'm going to ask you about pricing. And you already alluded to it yourself. You basically said, okay, we have this hedonic pricing result. And the interesting thing is that it's exponential. And of course, the exponent has a value. Now, my question is, do you see any further possibilities to work in this field of research, more specifically in terms of trying to understand the exponent, not only within the game, but also outside the game? Because in the real world, if you look at handbags or any luxury goods, you also have certain classes of quality, and you have the same exponential relation. And the exponent could tell us something about, for example, I don't know, inequality in society or something else. So do you see any prospects there? And could you give us your views on this?
Yes, thank you for your question. Indeed, one of the really intriguing things that we noticed but haven't been able to solve yet. So we have these 20 module classes. So we looked at we saw an exponential in basically any price structure of the models that we looked at. We looked at 20 models. We selected them based on objective criteria, depth of market, and they were all exponential. But the intriguing thing was that they all had a different slope. So what it means for the audience, some prices were rising not as fast as with other module groups where the slope was really, really rapid. And we haven't been able to explain that, but it's a really interesting observation. What determines the slope, the rapidness of rising, if you will, is something that I would really like to look into better. And it's one of the things that I would like to look into when we look at the heuristic pricing explanation. It's super interesting, but for now it's still a mystery, unexplained. Yes.
Could you explain to people what you mean by heuristic price explanation? Just because I think I'm the only one who gets you now.
Oh, sorry. Yes. So one of the biggest surprises of writing the dissertation was looking up the literature on the word heuristic. So what people mean with it is it's an intuitive decision-making process. So we have two ways it's better understood now, but still not completely. There's two ways of making decisions. There is, of course, the rational evaluation that people make when they consciously analyze something. You take mathematical functions, come up with something that tells you whatever in an active processing way. Any decision that you make without that process, for example, you go to the supermarket, you want to buy a bottle of milk, and you have 5 brands. You will pick one, or you will leave without a bottle of milk. But which one do you pick? This isn't a rational decision. So it's understood to be based on what we call heuristics. They're shortcuts to make a decision. When, for example, getting a bottle of milk, you don't want to do a huge analysis, but the complexity of the situation can actually be very big. Very few people could tell me why they buy what kind of bottle of milk. but everybody makes this decision every time they go to the supermarket. So that's heuristics. When I wanted to describe this in the dissertation, it opened up a huge rabbit hole. And I ended up writing an entire chapter on this way of decision making. And it's actually what I meant or what hinting to at the beginning of my presentation. We have only scratched at the surface of our understanding of how people actually make decisions. And what we wanted to do, to get back to the heuristic pricing paper, is if people, when they buy goods and they pay a price, if that is not based on perfect quantification of quality, because in most situations in the real world that's impossible, then how do they actually come up with this exponential? Where do you suddenly get an exponential from in the game as well? Very few people can tell me why they bought that item and not this item. But clearly with enough people, you get a market structure, a price structure that is exponential and very, very reliably exponential. So the heuristic paper that we're brainstorming on would be to come up with a more human explanation than the rational explanation that people quantify all this stuff and then assign a price to the quality characteristics and then sum it up together, because nobody can make this assessment. That's not how it works. How does it work? That is future research.
Thank you.
Thank you.
Okay, thank you. Let me turn to all members of the jury. If there is someone who would like to ask a second question, the opportunity is here. Please go ahead. Serge, Jacques, Nele, Louis, Bruno, Koen, Jan? All satisfied?
All happy.
All happy, then I give the possibility to people in the audience. So just shout and you have the opportunity to ask a question to Kevin.
Don't be shy.
Voila, this is a unique opportunity to ask a question to someone who is not yet a doctor, but soon will be.
The only chance to shoot at Kevin and not be shot immediately again, as in the game.
I see the hand of. I see
that one person raised their hand.
Eke or Ike, and a second Levi. So please, Eke.
Good afternoon. Is my microphone functioning?
Yes, we can hear you.
Good afternoon.
Maybe switch on the camera also. If
I don't have one available to my regret, so sorry.
No problem.
Kevin, first of all, thank you for the invite and the possibility to view this key moment here. I'm very happy. I've tried to formulate my question as proper as I could, and it consists of basically two things I'm curious about, and I hope you will want to answer them. First of all, in my experience with not EVE Online, but a specific other MMORPG, I know there are very important transitioning moments from, for example, one expansion to the other, and or one era into another. And these moments usually cause the entire market to extremely fluctuate.
Yes.
First, nearly all prices plummet, mainly to many of them becoming obsolete in the near future. And then the new expansion starts with new items. The prices of these new items are in the beginning extremely high, being only available for the rich in the first period of the era. Then later on, the prices stabilize and items gradually become affordable for the masses. In general, it's then when the so-called epic items kick in, and there you see the huge price difference between the mass market items and the epic items, who are significantly more rare. Now, my first question is, does EVE Online have such a similar structure where eras transition? Okay, then do you think do you see some parallel between what's happening in that game and what happens in the real world, for example, when a society rises, falls, or becomes really prosperous, or when a new technology becomes available.
Mm-hmm.
Do you see parallels between that?
Yeah. So the thing you point out, I immediately saw Koen smiling because it's something we've been looking at as well. It's super interesting. The first time you talk to researchers about this who haven't been doing it before, they start suggesting that we should get the makers of the game implement these changes and see how people react. And it's something game makers definitely don't want for a number of reasons. But it's a bit like with when the English broke the German Enigma code. You've broken it, but you can't use it. In only rare occasions you can, because otherwise people will figure it out and they will, like the Germans would have figured it out and they would have changed the code. So you have this thing, but you can't use it. In this case, we have a live agent-based model, but we can't like bound it with research questions. The expansions that you point out are extremely interesting for us as researchers because they are natural experiments. They are an introduction of a new technology, but it happens naturally in the game, and suddenly we can look at, as researchers, look at what happens around that dynamic. And we see very interesting things. In EVE Online, you even see players speculating on the changes that will be introduced into the game. So that, of course, ties immediately into finance, where you get speculative behavior. People prepare for this introduction of the new, whatever it is, the new stuff, and then you see the market explode anyway. And that most likely has to do with the initial rarity of the items being introduced, even though players know that the items will become available. Some people want those items the first day, and it can also be social value. Look at me, I got this item on the first day. I didn't wait like a peasant before everybody could afford it. So you see these price fluctuations that are in a way irrational, because you could just wait for the same item and 10 days later you would have it. I think compared to other games, the EVE Online situation is slightly different because in EVE Online, when a ship is destroyed or items are destroyed, it's gone from the game. Many other games have this situation where when an item has been around for a long time, everybody has it. It's styled, it starts to pile up, and there's no mechanism in the game that actually removes the items. So you don't have a natural creation and destruction cycle in most of these other games, which makes it different from EVE Online. For example, the epic items that you mentioned, in EVE Online, if you use epic items, they will get destroyed. And if they're very expensive, yeah, the destruction policy makes it much more realistic. Whereas in games like World of Warcraft and EverQuest, after a while, everybody has the best items, and all the other items are worth, in comparison, zero, and prices bottom out to basically raw production costs. That is still very different in EVE Online because of the destruction policy made by the game makers. They decided it will be a hardcore game, libertarian markets, and if you lose your ship, start saving again. Did that answer your question?
Is that okay?
Great question, by the way. Thanks.
Yeah.
It did answer my question, and it brings me to the second question, which is way shorter. Do you think your field of research is about creating such a model? And I can only assume.
Can I interrupt you, Ike? I think there's other people with questions as well.
Oh, sorry.
If there aren't, of course, go for it.
No. Ike, continue, but I've seen questions from Levi and Hans Amel, but maybe first finish, Ike, then there is time for the other people.
Okay.
I can only assume that you've been studying this field with the idea to have such models available in the future in real life or in real life situations. And do you think that it might be possible in the future to have such models predict situations of transitioning, predict how prices will valuate or devaluate in the real life world when, for example, a very new technology becomes available, and how that will affect, when it will affect like the top layer of society, and when it will become available for, well, that.
Yeah, good question. I think at the moment this so a lot of research has been done into computer games to study them as computer games. A lot of research has gone into virtual worlds to look at how virtual is different from real and how people behave inside the virtual world. Looking at virtual worlds as a model or testing ground for how real people behave is very new. I do think that if we do this for a while, we will see, and maybe also with new games that come out after EVE Online, the more the better, actually. The more we can compare, the more we can see whether a pattern is really a pattern or idiosyncratic to a specific game. And so we would like more of these models to appear. Of course, making these models is tricky, but I do think that with experience, we will learn things about real people in the real world. And I do think that this going forward will be really interesting, but we'll have to give it a couple of more years and see what comes out. The world is, of course, very complex. So answering the question now, I would love to be able to, but I don't claim to be able to.
Thank you.
Okay, I think there was a second question from Levi or Levi. Levi, go ahead.
Hello. She already asked it, I think.
Levi, go ahead.
Yeah, hey, Levi.
Hey. Yeah, can you guys hear me properly?
Yes.
Yes, okay, perfect. Well, what I was wondering, when you were describing the purple items, the luxury goods, so to say, it's in some way reminded me of diamonds, which buy social value, but is also something that people buy as an investment in times of crises or in wars. Is that a similar thing you see with the purple items, that when a war is raging, people invest in it in a way to like keep their resources safe?
Ah, good. Interesting. There's a lot of investment behavior in EVE Online. There's way less reliable data on investment behavior. For example, we've looked at the top investors, or talked to, we know them well. The top investors in Plex is another item, also very valuable. And there's speculation, there's hoarding, there's trying to corner the market, there's all sorts of stuff. You see the results in the EVE Online market, but why people do it and when they do it and such is much less clear. To get at the purple items specifically, what you get are dynamics between two major wars. And actually, at the moment, there's a major war going on again. So EVE is very exciting for researchers again at the moment. So people tend to accumulate these show-off ships, the big titans with the best items. And then there comes a point where everybody sort of has their prime show-off item, and maybe you can get a second one, but you have less incentive to have a second purple titan. And prices tend to go down because the supply of these items won't necessarily be less. They're still extremely expensive. You can find one, you can sell them on the market. It's awesome. And maybe this would be a time where people would start buying the items as they get less expensive to then wait for when the market goes up again. And that tends to be disruptive, non-linear with a war. When people field these ships, some are destroyed, and then suddenly the demand for these items goes up again. And I'm certain that people speculate on these things, whether it's a huge speculation market in purple items because they're so expensive that not many people have access to speculating in this market. Plex is most likely has more volume when it comes to speculation, but it's EVE Online. You have people who never shoot at another person, and their way of warfare is what they call market fu. It's the kung fu of EVE Online markets, and you defeat the other player by speculating against them, buying, selling, even all sorts of market warfare going on. So definitely you can count on speculation being everywhere. And purple items, I certainly wouldn't be surprised, yes. Finding reliable data, that's something else. If you find data like this, let me know.
If I do, I will.
Yeah.
Thanks. That was a very good answer. Can I ask a second question as well?
I would look at the chairman. Yes.
Yeah. What you told about value in game kind of reminded me of this TED talk I once saw. I just Googled his name again. I think his name was Adam Carroll, who played Monopoly with his kids with real money to observe how their behavior changed. We talked about behavior changes in real life versus virtual life, but that one was specifically aimed at behavior around money, buying and saving. How do you correlate, or did you look into that in your research,
yes.
like money specific?
Yes, so very good. Important to understand why players take this game so seriously is that two things. The destruction policy in EVE Online, if you lose your ship, it's gone. If you lose your fancy Titan, it's gone. And also, all ships in the game can be bought with money, ISK, the in-game money. And there is, the makers of EVE Online have a Plex system in play where you can buy this ISK with real life money, not directly, too much detail, not important. But that means that everybody in the game is aware that, for example, 1.3 billion ISK is one Plex, old Plex, now 500 Plex, whatever. And Plex has a dollar value. So you can calculate the value of all your ships, all your items in dollars, which means that you couldn't do the experiment you described in the TED Talk in EVE Online because everybody is calculating in real life money when it's about lots of money. And just to give an example, when I was doing, like in the time frame that we looked at in 2015, a Titan was worth 80 billion ISK in-game. And that had the equivalent of $3,000 to $4,000 US. So if you field the ship, and there was the big battle of B Tucker 5 or B around our data set, where I talked to people at Amsterdam who fielded their Titans and lost it, and still were waiting for the field commander to reimburse them. You're talking about $3,000 to $4,000 US in real life money. So you take that very seriously. I don't know. Most people, for most people, that is a significant amount, even in the real world. So you treat these virtual assets like having real world value. You don't want to lose them.
Yeah. Okay. It sounds a bit like when you go abroad and have to pay in different valuta.
Yeah.
But it does have an influence, I feel, on how you buy things.
Yeah.
If it's not the valuta you're used to.
Okay.
Yeah.
No, I have to stop the discussion here. You can continue later because I've seen 3 more people asking questions, and I have to stop this at 5:45 because the jury still has to come to a deliberation within the 2-hour period, you know. So there was a question from Hans Amel.
Hey, Hans.
Hi, Kevin. Congratulations. It was a very interesting presentation.
Glad you liked it.
I couldn't help but notice when you were talking about the temporal networks, about the Russian bank, that your first zombie was not the actual bank to die off, but the bank who died off was a healthy bank in the first layer. Is that intentional, or was that just a fluke in your diagram?
Very good question. So the diagram I showed is a diagram in the paper, and it clearly states that it's an idealized situation to explain how this stuff works. Now, we know in the real world that there are situations where banks who have a bad balance sheet can offload their debt to other banks, or maybe less suspecting investors, and therefore save themselves by offloading their losses that eventually will become realized. Yes or no? Because I mean, zombie banks nowadays can survive for quite a long time. But there's definitely cases where banks save themselves by wrecking other banks. Yeah, it's the world of finance, especially in banking. There are no nice guys. And banking is super important for the economy and for society, etc. But if you read stories from the U.S. banking, but everywhere, it's hard money. Yeah? When money's on the line, people get rough.
So it's actually a healthy bank. That bank is actually healthy and was killed off by taking a bad investment from a zombie bank. Is that something that can be detected or be guarded against?
You would expect all banks to be doing due diligence, to be in detail reading the balance sheet of this other bank before making the loan. But caveat emptor, so to say, if you invest your money in another bank and you made a bad investment, that's going to be the case. Of course, if it's fraudulent, then the regulators should step in. Note my careful wording here.
Should, yeah.
But this is like banking as a whole, super interesting world. I actually owe it in large part to Professor van der Vennet, who explained quite a few things about it to me. And yeah, it's super interesting. And again, yes, the example isn't fictional. Let's put it that way.
Perfect. Thank you.
Okay, we can still have two questions, and one from Roland and one from Gilles. Roland, you have the floor.
Hello, Kevin.
Hey, Roland. I'm afraid already.
Yeah, I just have to ask a question.
No, bring it on.
No, it's very simple. In the game EVE Online, I don't know the game that much, but can players actually die? So you say they invest a lot of time and effort in their character and in building their environment, and that's a driving factor for them.
Yeah.
But can they actually die in that game? And maybe first answer yes and no, and then I can continue my question.
Well, it's complex, huh? But the question is there permadeath in the game? The answer is no. However, up to a couple of years ago, when you died, you lost. So if you lose your ship, you die. No. If you lose your ship dies, and then you are ejected in a pod. It's just a game mechanic. You still survive, but your ship is gone. And then people can also shoot your pod, and you are resurrected, but you used to lose skill points. And so it's not a permanent death, but you still lose on death, and then you have to start trading those skill points back again. A couple of years ago, that was removed as well because it was a bit too harsh. It actually created an incentive for people not to play the game, beyond actually losing your ship if you played the game. So that was taken out of the game.
Yeah. Do you think the dynamics of your economy would change if a death of your ship would mean your character permanently dies and you have to start all over again with your character?
Very good question. For the scope of our research project, we actually wouldn't want this, because we'd like markets to be a proxy, like EVE markets to be a proxy for real world markets. And if you make a bad investment in the real world, you lose your money, the equivalent of your ship, but you're not shot. Usually you aren't. In most cases you aren't. So in the real world, you survive as well. So that's a good thing, actually, that it doesn't happen in the game either. Everyone muted.
Okay. Yeah, thank you. Sorry for the noise on the background.
That's okay.
Thank you for the question. Yeah.
Okay, there's a last question from Jill. Jill, go ahead.
Hi, Kevin. First of all, congratulations. Sorry for pestering you with the final
No,
question.
it's good. Actually, I'm inviting questions. I like talking about this stuff.
It's more about the metadata of the data set. I was wondering if during your studies of this mass data on the economics, if you've discovered some similarities as to the inequality of the distribution. Yeah.
Very good question. Continue.
Yeah, what I'm looking for is, does the virtual world have the 1% of multi-millionaires or not? And does it stay the same? Do the rich stay rich and the poor stay poor? Or is there a different dynamic there?
Yes. So yes, and we also looked at this. And so first of all, there is data on player ownership of ISK money. But it's difficult because players will also keep a high amount of value in their other assets, and you'd have to tally it all together. So with the caveat of this may be wrong, we looked at just the ISK distribution, and the inequality coefficient, so the Gini coefficient, when we looked at it, we concluded that EVE Online had a similar inequality level as Angola in the real world. So that's maybe not a compliment for EVE Online or for Angola, but so there is high asset inequality. Well, money inequality. It's not income, but the money you have. Whether that means something is a bit early to tell, and we didn't have complete data on item ownership as well. But it was interesting nonetheless.
If you have no government, you get inequality.
Yeah.
Thank you for answering the question.
Okay, thanks for everyone in the jury and people in the audience for raising these questions. The jury will now withdraw for a final deliberation. I have to ask members of the jury to close this meeting, so leave this meeting. Otherwise, everything you will say will still be heard, so leave this meeting. And then we'll be back in a few minutes.
Dank u wel, Lode. Dank u voor te komen. Even we can talk now if you want the.
It's really interesting. I've done a lot of network analysis. There's lots of things I've done in the past kind of came together, and really, it was much more interesting than I thought it was going to be. So congratulations! It's really great. They're really, really interesting stuff.
Yeah. I'm glad on how some of these things came together. Oh, Arjen has a question. If you want, you can switch on until the professors come back. Then we have to switch it off again. But if you want, you can activate your mic and your.
Kevin, can you hear me?
Yes, I can.
Okay. I would like to ask a question. I know nothing about games and things like that. But
come on, you played Pac-Man before.
yeah, but I would like to know where, when, and at what time is the reception. You know, that's for me more important.
Immediately getting to the important stuff, eh? We have to wait for the jury to make a decision, which I find quite important. And after that, normally Koen will say a word. I will thank basically everyone. And then normally we are asked to join us for the reception, but of course, in this case, I can do that as well, but we will do it remotely.
Okay. Bye.
I agree,
Okay.
Crystal.
Whew. Hey, Aaron, I'm glad you could come.
Yeah, you know, it's 2 a.m. here, but
Yeah.
I
This
stayed
is
up
my
just for
caller
this.
from Japan.
Wait, you're all the way from Japan? No way.
Yes.
Oh my God, that's cool.
So
really glad to see you that you could make it for it, because of course, yeah, 2 a.m. on a Thursday night.
yeah. So I'll sleep a couple hours before going back to the lab.
Yeah. Exciting.
How do you feel, Kevin?
Excited, actually. I was a little bit nervous, but more about the technology not working. Like if MS Teams had decided today to not show, I would have been annoyed. For the presentation, I'm excited about the research that I did and also how it came together. So I was excited about being able to show it to you guys. And it's also the preparation, of course. You've made the PowerPoint, you know whether it's clear or not. So that was really cool. But yeah, so excited, anxious. Let's see what the professors decide.
Well done, Kevin.
Dank u wel, dank u wel. I'm seeing a bottle of champagne already. This is just a tad premature.
Okay.
We are ready for the verdict. It's
After
not
all
opened
the
yet.
things
But,
they said, they just talked about it, and no, that won't do, Kevin.
It would be sad if the answer now was no. We ran out of free positions for doctors.
The PhD printer is out of order.
As long as you're not filling it up with beer and whiskey chasers, you'll be fine.
Yeah, we would still open a bottle of champagne.
That's it. Alcohol
Alan
can be a
doesn't
solution to
remember
any.
much after he passed his.
Exactly. Yeah.
Anyway, it's better champagne than water, isn't it?
There's always an occasion for champagne.
I agree
That was
with
Kristen's hand. It could be to celebrate, and it could also because you're sad. You open a bottle of champagne to make you feel better. But let's hope it's celebrated.
Every day is a day to celebrate.
That is also true. Let's not, especially in these times, let's not forget that.
Ah, now we see the people. That's nice.
Congrats. Congratulations.
Is there a...
Okay.
Is it a congrats?
Everybody's... Hey, Aaron.
Hey, Koen.
Hey, man. Good to see you. Could you follow something?
Yeah, members of the jury, members of the jury are back. I see Koen. Jan, Louis.
Switch off the cameras again, please.
No,
otherwise,
okay.
Yeah, I'm here.
I don't want Teams to switch off now.
Louis, are you back?
Yeah, this time I'm back.
And Jan is back also. Nele, Bruno. Yeah?
Yeah, I'm back in town.
Okay. So, ladies and gentlemen, the examination board has decided, after deliberation and unanimously, that the degree of Doctor of Economics and of Science, Physics, will be granted to Kevin Hoefman. And I could say now, please, you can now switch on your cameras and you can switch on your micro, and then you can just express your...
Amazing.
That is a relief. It's been a long but
Kevin.
very interesting journey.
Kevin, on behalf of the examination board, on behalf of the whole faculty communities of economics and business administration and of science, physics, I warmly congratulate you for obtaining this high scientific degree. I congratulate you also on the side of the Department of Economics. You know that having young people obtaining their PhD is important for the department, so we're very happy with your results. Thanks a lot.
Thank you.
You know
Thank you
that.
very much.
Yeah, maybe that the people now switch off the microphones again.
We need the wine, my darling.
Not yet, not yet.
You know, Kevin, that but this is impossible online, but from the Faculty of Economics and Business Administration, from the Department of Economics also, you will still receive a diploma and a few presents. You know, the Dr. Barre, the Faculty of Economics pen with your name engraved in it, Dr. Kevin Hoefman.
Awesome.
The present also from the Department of Economics. I can't give them online, but you will still receive them. Sure of that. So before immediately giving the floor to the supervisors for a short laudatio, and to Kevin for the final word, I can now declare this extraordinary examination time closed. I thank the members of the jury. I thank the members of the guidance, the Doctoral Advisory Committee. I thank in particular also the audience for joining us in this important event. Thanks all, and then Koen, the floor is now yours for a short laudatio.
Okay, can you hear me?
We can hear you.
Okay, thank you so much. So ladies and gentlemen, I'm going to walk you through a little story of this PhD to remind us all of how it happened and when it happened. First of all, I got to know Kevin as a student in the Master of Banking and Finance, as he already told us, with Rudy also as a professor, also Rudy van der Vennent. And he already then was a bit of a special case, as you all know. He wanted to study banking and finance, but from a background of engineering and with a clear desire to change the world and the world of banking. So I found it an interesting character, and initially, when he expressed his willingness to do a PhD, I paid him on some of my own money I saved up, because I like to spend my money on people and like to invest in people I believe in. And so that's how it worked. So that was my pleasure. So what he didn't tell you is the first thing he did is he worked on getting data from an old, massive Russian data set of number plates. And that involved some inventive screen grabbing, C++ coding, and a battery of very old computers, 32-bit computers, burning through countless memory cards. And basically, you have to imagine like an old movie scene, a computer hacking movie scene with all kinds of old computer machines, heavy metal music from the speakers, and like months and months grabbing data. That was very interesting. Later, we started to brainstorm, and we came to an idea together with Jan Rijkebus, the co-promoter, to apply for a research grant based on the idea of building this live agent-based models, where the essential idea, the hypothesis is that we could use data generated by these games, this massive multiplayer, you could say sandbox games that never end, to say something about the real world, and basically to test existing theories about the economy and about politics, and maybe to formulate some new theories. I thought initially it was a bit of a crackpot idea, actually, and we had no idea how to even start with it. So in short, it's precisely the way I like it, because I'm a high-risk academic, If it looks easy and not crazy, I'm not even interested. So it was the perfect project for me. And luckily enough, we got the project and then we had to do it. All once we got to do it and we have no data yet. So our game of choice turned out to be EVE Online. You already heard about EVE Online. And I'm sure in the audience you have some players of this game. You all know it's brutal, it's fascinating, it's addictive. It's about production, it's about logistics, it's about trade, it's about politics. It's about violence and cooperation. It's about war and peace. It's, in short, a little bit like life itself. And that's precisely the idea. In fact, that's the whole idea. And I remember vividly getting into contact with EVE Online together with Kevin. So basically, without any further thoughts, we just booked the tickets and went to the Fan Fest in Reykjavik. That's a juicy memory in my academic life. We were only armed with ourselves and our wits, and basically the idea was to talk ourselves into getting into contact with the company and convincing them to share the data. At the same time, there was a solar eclipse. Remember this, Kevin? They planned and the solar eclipse. That was really very special. So yeah, it was interesting. I remember sitting in a room with 2,000 of these fans, filled, mostly men, mostly a bit too fat, mostly clad in black. And there was a palpable excitement. They were watching a movie about a new technology. That was also one of the questions. And everybody was extremely excited and said, oh, and I had no idea what I was watching. But they all understood. They knew the context, and it was really interesting to see how they lived through it. It was vibrating with excitement, the whole, and you had the tribes, the characters. It was really something else. So we convinced them to get access. And also remember that you, together with Milan, who should be mentioned, you spent a massive amount of effort in Iceland to get the data as quickly as possible, as much as possible. And that was the groundwork of a long string of papers presented on various conferences. We have mentioned Zaragoza, where we picked up Andres, by the way, mentioned Amsterdam and other places. And this was also always, to a large extent, a collaborative effort with the varying set of researchers from the team. And in alphabetical order, I should mention Aaron, who is also watching and who had a huge contribution. Andres, of course, Benjamin, Jan, Kevin, myself, Cornel, and Louis. We have political balance theory, pricing theory, temporal webs, relation with the real world, gravity theories, and also stuff mentioned today. Relation with technology and inequality. What is it saving up for a crisis time? Is it diamond? Good questions. And so there's more to come, I'm sure. So in a way, you could say the whole project, although it was totally crackpot, has, with hindsight, been an astounding success, an unexpectedly great success. Still, I should mention, you always kept your desire to change the world also inside the department. And Kevin had two main missions. One mission was a sustained campaign to make a substitute fat for sugar. He's against sugar and pro-fat. I must say the campaign was not totally successful because birthday cakes are still the mainstay of his life. But on the upside, Kevin, birthday cakes contain a lot of sugar and fat, so you can still think of it as a half win in a way. We eat at least the fat, but still the sugar also. There was also another interesting campaign inside our department about computer languages. And it was a campaign to decide the fates of C++, Julia, and Python. And it seems Python in a way won, because even C++ codes get converted to Python. On the other hand, we now have Louis in the department, and he also is a C++ guy, and maybe it's gaining some traction again. But Julia, on the other hand, has all but disappeared from the radar.
Oh.
But then again, who knows what the future will bring, come what may. The last thing I want to say also is something personal. I enjoyed working with you. It was not always easy, but it was always fun and exciting. And also, one of the things I learned from you, maybe you don't remember, but on a birthday party, you organized a geo-tracking thing. Remember that? And one of the things my daughter does now every weekend after that is geo-tracking. So that's one lasting result of our collaboration. But in any way, congratulations, thank you, and may the force be with you. Koen.
Thank you.
Kevin, the last word is yours.
All right. So I have to thank basically everyone, but it's only fitting to start by thanking my promoter, Koen Schoors, without whom this whole project would not even exist. Koen is the man of the 1,000 ideas, half of them crazy, most of them brilliant. And when Koen considered computer games as testing grounds for economic and social theories, he saw potential where others saw risk. And his enthusiasm translated into a funding proposal which, as Jan said, the jury could only accept. And they did not only accept it, they provided funding for a whole team of LabM researchers, like Koen already mentioned. And this dissertation is only one of its tangible results. So Koen, thanks a lot. Literally, this project would not be without you. Second, I also want to thank my co-promoter, Jan Rikkebus, whose social physics research motivated the multidisciplinary nature of this dissertation. And I have to be honest, I didn't know social physics existed before I met Jan. I thought physics was about physics. But it's so much more than that. The models can be applied to anything. Jan's enthusiasm for exploring the correspondences between subatomic physics and human social behavior is inspiring, and I'm not surprised. I hear this from many students who've had Jan as their teacher, that they consider him their favorite teacher at the faculty. I also want to thank my main co-author and mentor, Aaron Bramson, who made it all the way from Japan virtually, but still is 2 a.m. there, probably going on to 3 a.m. already. And Aaron was instrumental in bringing the academic publications in the dissertation to realization. Without Aaron, we wouldn't have the papers. And of course, academic research is all about publications. So Aaron, thanks a bunch. I also want to thank the members of the jury for their valuable insights, and the chairman, Professor Helen, for hosting this event. It's super important, of course. A journey is only half a journey without a conclusion. And research does not happen in a vacuum, so I also want to thank the staff, the LabM guys, Milan, Andres, Benjamin, Ken, for being their inspirational selves. I also want to thank Vicky and Tom, with whom I had many conversations on many different topics, often to the bewilderment of our other dear colleagues who were trying to get some work done on the other side of the office wall. To my family and friends, most of all, of course, my parents, thank you for everything. And of course, I want to thank Crystal, my amazing wife, wine lady and champagne ambassador, without whom I probably would have starved to death 5 years ago. And finally, I want to thank everyone in the audience for showing up, showing your support, and for taking pity on me and being nice and only asking the easy questions. So thank you, everyone. Thanks a whole bunch. And let's have some champagne.
Congratulations, man.
Yay!
People who want to continue talking to Kevin, you can continue. Huh? There's no reason to leave. People who want to leave, of course, it's now all closed, but just go on. Kevin, congratulations and see you soon.
Thanks again. Thank you.
Congratulations. Huh?
Thank you. And bedankt, Freddy.
Congratulations.
Congratulations.
Yay.
Yes.
Hi, Chris. How are you?
Cheers.
Congratulations, Kevin. Well done.
Thank you, thank you, thank you.
Congrats. This is really great to see.
Oh, the champagne is arriving.
The
champagne is here, but the people are arriving.
Kevin, now you can show the real background.
But we'll keep that for
Doesn't matter anymore. Doesn't matter anymore.
Stop recording.